We're going to continue our study of the law of signs today, talking about the ambiguous case. Last year on the Regents exam, the word ambiguous was one of the vocabulary words. What ambiguous means is it's unclear, or it could be more than one thing. So you should know what ambiguous means, unclear, or not definite. Ambiguous. And the way they usually ask this question, or how I'm going to ask it, is how many triangles can be constructed with the given information? In this situation, two sides of a triangle are given and another angle that is not included between those two sides. That's called side-side angle situation. And down here are three pictures of side-side angle situations. And if you're given side-side angle, you might be able to build or construct one triangle from the given information. If the situation is like this, if you can just drop a perpendicular down, and this A and this B will only create one right triangle. Sometimes you're given information where the side little a is too short to even construct one triangle because it doesn't reach all the way down to the base, given this B and this angle A. This angle A is fixed. And sometimes they'll give you the length of side A where you could actually construct two triangles if the side A is swung around in this direction. You might be able to construct this little obtuse triangle here. Or if you take this side A and swung it around like this, you could actually construct this triangle here with this side A. This side A is equal in length to this side A. So you could construct this acute triangle with the given information, or you could construct this little obtuse triangle because this A could be in two different situations. And when we go through some examples like this, you'll see that it's not all that tricky. It's tricky to explain, but it's not too tricky to do. So when you are given side-side angle information, usually you're going to draw a picture and you're going to see that you don't have side angle side, but you'll have side-side angle. What you're going to use is the law of sines. Side-side angle means you're going to use the law of sines. And usually the question is, how many triangles can be constructed? The answer will either be 0 or 1 or 2, and that's it. You'll never get 3 or more triangles. So to find out how many triangles can be constructed, you're going to follow these 3 steps. First of all, you're going to know that side-side angle requires the law of sines. And when you use the law of sines, you're going to find a second angle depending on what they give you. Like in this situation, if you're given side A and angle A and side B, you're going to find out how big angle B is. Then you're going to have to determine the supplement, which means 180 minus the answer that you got in step 1. Because 180 minus this answer in step 1 would give you a quadrant 2 angle. If you use the law of sines to find the second measure, the second angle's measure, you will get a quadrant 1 angle. In other words, you'll get a reference angle when you do the law of sines. But since sine can be positive both in quadrant 1 and 2, you're going to figure out what the supplement is. So just 180 minus this answer you got in part 1. And then you're going to check to see if the sum of the angles will be enough to give you enough room for 180 degrees in the total triangle. So we'll go through these 3 steps in some situations here, and hopefully this will make more sense than it probably does right now. the question is, here's the big question on all of these, how many triangles can be constructed with the given measures? So we're given the following information about a triangle ABC. How many triangles can possibly be constructed? So how many triangles? The answer will be either 0 or 1 or 2. That's it. So here we've got triangle ABC. Let's draw this. Triangle ABC. They're telling us angle A is 35 degrees. They're telling us that little a is equal to 9, and they're telling us little b is equal to 12. So what we have here is side angle. We don't have the angle that's in between the two given sides. We have side angle. So with side angle information, we say to ourselves, this is the ambiguous case. So what we're going to do now is, please do this with every type of ambiguous case you have. You're going to set up two charts. This first chart is going to have the A and the B and the C information, and this is the first possible, oops, I spelled possible wrong, it's got two S's, first possible triangle. And the first possible triangle will have three angles, A, B, C, and three sides, A, B, and C. And what you're going to do is fill in the given information. This does not change. So we've got 35 degrees, side A is 9, side B is 12. Then right beside this chart, you're going to draw an identical chart. And this identical chart is the second possible triangle. Remember, you could either get two triangles or one triangle or no triangles at all. So let's do an identical chart here for the second triangle, just in case we can build a second one. A, B, and C. And A is 9 and B is 12. So the given information, this given information goes in both the charts, all three of them. And so now the first step says use the law of sines. Well, the law of sines we're going to use has A's and B's in it. So that'll say A over the sine of A is equal to B over the sine of B. And we're going to fill in some information. A is 9. Angle A is 35. B is 12, but we don't know what big B is. So just like yesterday, with the law of sines, we're going to cross multiply and divide. So we have 12 times the sine of 35 is equal to 9 times the sine of B. That's the cross multiplying. And then you're going to divide both sides by 9. So you're going to get a sine of B answer. So let's do this on the calculator. I'm going to set up my fraction, and it's going to say 12 sine of 35 over 9. And so now we have to take these decimals out 4 places. So I have 0.764. This 6 rounds the 7 to an 8. So rounded, this will give us 0.7648 is equal to the sine of B. And to get angle B, make sure your mode is in degrees mode, and you're going to do second sine of that answer. And your angle, we're going to round these angles to the nearest degree, so the angle B is about 50 degrees. So when we get this answer, 50 degrees, we're going to put it in this chart. This angle B is 50. And then we're going to add up these two angles. 35 plus 50 is 85. And 180 minus 85 is 95. So actually we have enough room to give one triangle. If all three of these angles can be filled in, adding up to 180, we have one triangle that can be constructed. Now what we're going to do is step 2 says 180 minus the answer to step 1. Well, our answer to step 1 was 50 degrees. So step 2 says 180 degrees minus 50 degrees. That will be in our second triangle. This 50 degrees is in the first triangle. The 180 minus 50 is in our second triangle. So 180 minus 50 is 130 degrees. And we're going to put that in our second possible triangle, 130 degrees. Because the sine of 130 degrees is the same thing as the sine of 50, which is about 0.7648. So you actually could have two different answers. So now we're going to add these two up and see if we can fit an angle C in there. 35 plus 130 is 165, so we actually have enough room for a 15-degree angle because all these angles must add up to 180. Every once in a while we get an angle that's too big, like if we got 170 degrees in here, then we would have too many degrees already and we couldn't fit an angle C in here. So these two columns must add up to 180. So we have a complete first triangle filled out. It would be 35, 50, 95. And then we have a second triangle filled out, a 35, 130, 15-degree triangle. They're totally different triangles, so we would have a situation like this up here. So the answer is 2 triangles. Example number 2. We'll draw our ABC, and angle A is 82, BC is 12, BC is little a, AC is 11, AC is little b, and we have side-side angle situation. So side-side angle means the ambiguous case, and the ambiguous case means we're going to possibly get 2 triangles. Let's see if we can or not. So we set up our chart with A, B, and C. And remember, the given information goes in both. So angle A is always 82, little a is always 12, and little b is always 11. So our law of sines says A over the sine of A is equal to B over the sine of B. A is 12, angle A is 82, little b is 11, and we don't know what angle B is, but we're going to figure that out. So we're going to cross multiply like we always do with the law of sines, and we get 11 times the sine of 82 degrees divided by 12, I'm going to do 2 steps in one, is equal to the sine of B. So the next thing we're going to do is take our calculator out and calculate what is 11 sine of 82 divided by 12. Well, that's 0.9077, and that is the sine of B. So now we're going to do second sine of that answer, and angle B is about 65 degrees, approximately, angle B. So what we do with the angle B is we put it in this first triangle, 65 degrees. This is our first possible triangle, and this is our second possible triangle. So when we add up 82 plus 65, we're going to get 147. And 180 minus 147 means we can have a 33-degree angle left. So we have one triangle that can be constructed. The next step we're going to take is we're going to get the second triangle. This is our first triangle, which is 65 degrees, but our second triangle is 180 minus 65 degrees, which is 115. So now angle B, we're going to put 115 degrees in here, but if you add up 82 plus 115, you're going to get 197 degrees. So there is not enough room to put an angle C because these two already add up to more than 180. So with this situation, you cannot construct a second triangle, only the first triangle. So the answer, instead of 2 triangles for example number 2, is 1 triangle. can be constructed. Two more examples. And they all follow the same steps. You'll get used to them after a while. Angle B is 79 degrees. AC, which is little b, is 10. AB, which is little c, is 15. So that's the given information. So we're going to set up our two charts. Put in our A, B, and C information. And the only angle we know is 79 degrees. And we know little c is 15 and little b is 10. Remember to put the given information in both charts. And now with our law of sines, it's going to say b over the sine of b equals c over the sine of c. So b is 10, big B is 79, little c is 15, and we don't know angle c. We'll figure that out in a minute. So when we cross multiply, we get 15 sine of 79 divided by 10 is equal to the sine of c after you cross multiply and divide. So we'll take our calculator out, and we will get 15 sine of 79 over 10. And we have 15 sine of 79 over 10. We have 1.4724. And if you remember, if you do a second sign of that answer, it's going to give you an error because you can't have a sign that's bigger than 1. Oops. So what we're going to say here is this is too big. It's like rejecting from our last chapter because the sine of c must be less than or equal to 1. So since this is greater than 1, you can't have an angle C. So there is an x here and an x here, and your answer is 0 triangles. And that's because of this situation, the sine of C being too big. And then we have one more situation here, or one more example of an ABC triangle. Let's see, you know what, I'm going to make C up at the top because that's our obtuse angle. I'll make this one angle B. So angle C is 109, little b is 20, and little c is 19. So our given information is angle C is 109 degrees, little b is 20, and little c is 19. And now we have our law of sines that's going to work with b and c. So we have b over the sine of b is equal to c over the sine of c. B is 20. We don't know angle b. C is 19. And angle C is 109. So now we're going to cross multiply and get 20 times the sine of 109 divided by 19 is equal to the sine of B. And then we're going to pull out our calculators and see if that's going to work. 20 sine of 109 divided by 19. Yep, that'll be okay. 0.9953 is equal to the sine of B. Well, that's okay because it's not greater than 1. So now we can do second sine of that answer and get 84 degrees. 84 degrees approximately is angle B. So now we're going to put 84 into here. And then 180 minus 84 goes into the second. Here's our first triangle. Here's our second triangle. Our first triangle is 84. Our second triangle is 180 minus 84. 180 minus 84 is 96. All right, so we're going to put 84 in this first chart, and we're going to put 96. Because 180 minus 84 is 96. So what we have here is when we add these two up, 109 plus 84, they add up to more than 180. So you can't produce a triangle here, and when you add these two up, these also add up to more than 180 degrees. You don't have enough room to fit an angle A in there. So that means, because in both of these situations, your first triangle can't be constructed, your second triangle can't be constructed. I didn't mark this. This is our first triangle, and this is our second triangle up above. So because you can't put an angle A in there, the answer again is 0 triangles. So I've given you an example of all three situations. You can sometimes have everything come out okay, but you're going to not have enough room to add another angle A once you add up the two other angles. Or you might, right in the very beginning, get a sign of C that would be too much to even calculate an angle. So those are the 0. Sometimes you could get one triangle by you're able to fill in one chart and get 3 angles out of it, but you're not able to fill out the second chart because you've got too many degrees already. Or a lot of times you can fill out the entire first and the entire second chart, and both of these will work, so you could construct 2 triangles. So that's it for today, and we'll get practice on this tomorrow. See you tomorrow.